In this tutorial, I will show you how to compute the p-value in a t-test. And in order for us to do that, we have to be provided with the test statistic. In this case, it is, and we have to be provided with the test, in which, in this case, we do have a right tail. And we also have to know which type of the distribution is involved. In this case, we are dealing with a t-distribution that has 22 degrees of freedom. And to find the p-value, we're going to follow these steps. First, we're going to draw the probability density curve. I'm just going to be using some generic bell curve, which is what all t-distributions look like, more or less, depending on the degrees of freedom. And after the first step is complete, we'll be drawing the region according to the type of the test, and then we'll label the areas and the test statistic, and then we'll compute the p-value. So let's get started. In this case, we already have completed the step 1, so let's draw the region in the right side of the distribution according to the type of the test. We have a right tail test, and then we're going to label the areas. So the only area to label here is the area to the right of this boundary, and the boundary is labeled, well, the boundary is our test statistic. So this is our t0, which is 0.5. And to find the p-value, as you can tell from this diagram, means to find the probability of t being greater than 0.5. And that's your p-value. Now, this quantity cannot be computed. It cannot be found using a t-table. T-table only gives you the critical values. So to find this quantity, you have to use technology, whether you use Excel or TI-83 or StatCrunch, you will get the same answer. I'm going to show you how to use StatCrunch because it's just the most visual way of all three that I listed. And to find this probability in StatCrunch, we're going to open the T calculator. We're going to make sure we have the right one. So we're going to enter the degrees of freedom, which are 22. And then we're simply going to copy this inequality over here into this calculator. And this is the probability. So it appears that the area to the right of the test statistic is 0.311. And that's our answer. Excellent. Let's try another problem. We have another right tail, so let's just try a new version. I want to see I want to do the left tail next, or two tail. But it doesn't matter which one you're doing, because we're all going to be, for all of them, we'll be following this 4 steps. You just have to learn how to follow those steps. Let's do another, let's shuffle again. And there you go. So now we have a left tail test, and to follow the steps, we're going to continue using the same sketch of the t-curve, and we're going to draw the region to the left side. We're going to label that boundary as our test statistic negative 0.8, and the area to the left is what the p-value is by the definition. So to find the p-value, we have to find the probability of t being less than the critical value negative 0.8. So to find this, I'm simply going to use the t calculator with 7 degrees of freedom, and I'm going to enter here negative 0.8, and I'm going to make this less than, and this is my p-value. It's that easy. The p-value in a left tail test is simply the area under the probability density curve to the left of the test statistic. And for the right tail test, it's the area to the right of the test statistic. It's that simple. So next, let's try to find the p-value in a two-tail test. And of course, when you need it, it's when you don't get it. So I'm just keep generating new versions. And finally, I got a two-tailed test. So I'm going to draw the region according to the type of the test. In the two-tailed test, we're going to draw the regions in both sides of the spectrum, and we're going to label the area region has half is what, so the total area of both regions is equal to p value, so each one of them is half of p. And now, because our test statistic is -1/2, we label the left side, the boundary of the left region with -1.2. So to find the p-value, we're going to first find the probability of t being less than -1.2, but that is only going to give us half of p. So to find the full p, we're going to multiply this by 2, and that's how you get the full p-value. So to find that probability, we're going to use a calculator. We're going to open the right one with 43 degrees of freedom, and we're going to find the area to the left of -1.2. But again, remember, this is just half of p because we're doing a two-tail procedure. So we have to multiply this by 2. And this is what the full p-value is equal to. So 0.237. And of course, we got the right answer. So next, I'm going to do one of each of the type, and I'm going to try just to use technology and walk you through the thought process instead of drawing out the diagram. Here's we have a two-tailed test with a test statistic 1.6. As soon as you open the T calculator with 49 degrees of freedom, you'll be able to tell whether the 1.6 is in the left side of the spectrum or the right side of the spectrum. So you see here, 1.6 is in the right side of the spectrum. So to find the p-value, we're going to find the area to the right of this test statistic. But because we're doing a two-tailed test, we're going to multiply this by 2. And this is what the full p-value is equal to. All right, and let's do one of the left tail and one of the right tail. To find the p-value in the left tail procedure, you simply have to find the area to the left of the test statistic. So in this case, it's -0.9, and that's it. And let's do one more of the right tail test. And in the right tail test, to find the p-value means to find the area to the right of the test statistics. So it's simply this. And let's check the answer. Of course, it's correct. So we did at least 2 of each type. So hopefully you understand how to find the p-value of a test statistic in a t-test. If you have any questions, let me know.